Hello dear students, welcome to the online tutorial of analog circuits. Today we are going to see small signal half wave rectifiers. Small signal half wave rectifiers using operational amplifier. So why we are using the term small signal? Because the signal that we can rectify using this technique should be small in amplitude. Okay, that's why we are telling that small signal half wave rectifiers. As when we know that what is half rectifiers. Half wave rectifier means either we can rectify the positive half or the negative half of a signal. That means if you want to have a positive wave rectifier, then in that case positive peak of the signal will be retained and the negative will be rejected. Similarly, in negative half wave rectifier, what will have? It will reject the positive voltage. Clear? Okay. So now based on this rectification technique, we are having two types of rectifier. Let us see. The first one is positive small signal half wave rectifier. So what is it? It can rectify signals with peak values down to a few millivolts by clipping off negative voltage. So negative voltage will be rejected in this case. Whereas for negative small signal half wave rectifier, what it will do? It can rectify signal with peak values down to a few millivolts by rejecting positive voltage. Now this operation can be easily realized using a combination of a simple amplifier and an diode. Okay, it will be very simple in construction. So first we will see positive small signal half wave rectifier. So you can see here on the screen circuit 5.4.A represents a positive small signal half wave rectifier circuit. Here it is nothing but a main thing that you should know, that it is nothing but a voltage follower operational amplifier. So I hope that you will be knowing what is voltage follower. In voltage follower, whatever input signal you will be giving to the op-amp, same at the output you will get the same output voltage. Clear? Now since here, if you will see the circuit diagram, this is the operational amplifier, this is the inverting terminal, and this is non-inverting terminal. To the non-inverting terminal we have given the input voltage V in, so it is non-inverting voltage amplifier. That means the same, there will be no phase shift, okay, between the input and output. The same whatever you are giving input, you will get the same output. And also you are having a short circuit between output and inverting terminal, giving a gain of 1. Okay, clear? So in this case, if we are having a V in like this, okay, you see the now input output waveform we will see. So this circuit diagram, figure 5.4.B, it represents the input and output waveform. So assume that you are having a input waveform like this, where you are having a positive peak at 100 millivolt and you are having a negative peak at minus 100 millivolt. So for this positive half wave rectifier, what will be the operation on this input signal? Only this positive side will be retained, okay, and the negative voltage, it will be rejected. Okay, so if you reject this negative voltage, you will end up in having the output like this, as shown in the here. Okay, like this you will have the output. Now how can you have the output voltage like this from this input voltage? Now you can have this operation by using a op-amp in voltage follower mode with a diode attached at the output as shown in the figure. Okay, you see the direction of the diode. So what will happen? See the operation of the circuit. Whenever you are having V in and V in positive, so the voltage here at this point will be positive. Okay, so whenever you are having a voltage this point positive, So what will happen? This diode will be in forward bias mode and it will conduct. This diode will be in forward bias mode and it will conduct. As a result, whatever voltage you are getting here, whatever voltage V naught dash will be there, same you will get that voltage here. So V naught will be equal to V naught dash, okay, for V in being in the positive side, okay. Now whenever V in moves to negative side, whenever it is having a negative voltage, okay, in this region, what will happen? For this input at this side, V naught dash will be negative and your diode is reverse bias and it will stop conducting. Once it stop conducting, the output voltage here V naught will be 0. There it is shown, okay. So that is why for this negative side of the input, the diode will not conduct. As a result, the output will be 0. That is why you can see the output waveform. So the output waveform from here to here, it is following the input. For the negative side, negative voltage, it is rejecting because D1 is off, and again for the positive, it is again conducting. So this represents, this waveform is nothing but the rectified, half-wave rectified positive rectifier for this input signal. Clear? So we will again revise this operation point by point. The op-amp is made to work in voltage follower configuration with a diode D1. Already I told you, as V in, that is input voltage, starts increasing in the positive direction, V naught dash. So where is V naught dash? V naught dash is this voltage. V naught dash is this voltage. Clear? So as V in starts increasing in the positive direction, V naught dash also starts increasing positively until diode D is forward biased. In this condition, the D1 conducts, the diode conducts, and output voltage follows input voltage V in. Okay, as it is also evident from the figure input output waveform. However, when V in starts increasing in the negative direction, D1 stop conduction. As a result, V naught becomes 0 as shown in figure 5.4.b. Okay. So this is the basic operation of the circuit to have a positive half-wave rectification. Now what type of op-amps we should use for realizing such operation? There is also one criteria. The op-amps used for this circuit must be of high speed, okay, of high speed, like mu at 318, H8, 2500, etc. So all these op-amps that I have mentioned here, its operation is high when it is of high speed. Okay. Why do we need a high speed operational amplifier? Because it alternates between open loop and closed loop operation. Okay. Because the op-amp alternates or switch between open loop and closed loop operation. That's why to have that switching operations, if switching operation is high, we need a high speed operational amplifier. Clear? Now again, if we make a minor change in a positive small signal half-wave rectifier, whatever we have just seen, then we can have negative small signal half-wave rectification. What is that change? It is mere the change of the direction of diode. Okay, you can see here. Now moving to negative small signal half-wave rectifier, the first thing, the circuit for negative small signal half-wave rectifier is exactly same as positive one, except with the change in the orientation of diode as shown in figure 5.5. So where is figure 5.5? This is the figure 5.5. Here it shows the circuit diagram and here it shows the output waveform. So it is very much clear. The explanation is same as what we had for positive half-wave rectifier. So it is once again we will see this. Okay. So as V in starts increasing in the positive direction, V naught dash also start increasing positively. So if you're having at this end, if you're having a positive voltage here, then what will happen? This diode will be in reverse bias. For this positive voltage, the V0 for this side, for this cycle of voltage, for this period of voltage, we're having the value of the voltage is positive. V0 dash is also positive. And if V0 dash is positive, then D1 is also in which mode? It will be in reverse mode. If it is a reverse mode, it won't conduct. It won't conduct means output will be 0. See, it output is 0. Same thing has been explained. And if it is the V0 is negative for this period, then this diode will be in forward bias mode and it will start conduct. So whatever input is there, you will have the same output. Okay, till here. Now again after this, what will happen? It will again, diode will be off. Okay, so as a result, the output will be the negative half wave rectification of the input voltage. Okay, so as V in starts increasing in the positive direction, V0 dash also start increasing positively. Thus, by bringing diode D1 in reverse biasing mode, as a result, D1 stops conduction and V0 becomes 0. Okay, for this region. So 0 will be for this. It will be 0. Again here 0. However, when V in starts increasing in negative direction, okay. However, when V in starts increasing in negative direction, D1 is reverse bias and reverse is this is not reverse bias, this is forward biased. So this will be forward biased. Whenever V in starts increasing in negative direction, D1 is forward biased and starts conduction. In this scenario, the circuit behaves as voltage follower and V0 follows V in as shown in figure 5.5.b. Clear? So this is your negative half wave small signal rectifier. Clear? So here we comes to the discussion of small signal half wave rectification using operational amplifier. Thank you.